And so we'll go ahead and kick it off. This is duct testing best practices. And to introduce myself, for those of you that might be new to our webinar series, my name is Sam Myers. I'm a building science and training consultant for Retrotec. I've been here for a couple of years now. Before my time here, I was a building science specialist for an engineering firm called Advanced Energy, located in Raleigh, North Carolina, where I'm still located now. And we'll go ahead and get started here. Retrotec manufactures two types of duct testers. We make one for residential and one for commercial, but for this webinar today, we're going to be focusing on residential, as both of those processes do vary quite a bit. For commercial, you're really kind of focused on the cabinet and the trunk line at much higher pressures. For residential, we're looking at the entire duct system at a much lower pressure. So for testing ducts and residential assemblies, we're going to either pressurize or depressurize that system to 25 pascals. And we also have a new duct tester shell out that we're taking orders for now. It's called the 300X. And for those of you that are familiar with the 300 series that we've been carrying, the yellow shell, you can see some differences here, especially in the footing. There's a much sturdier base to it. Some of the feedback that we've gotten from our customers is that they're actually, for higher ceilings, they're putting their duct tester up on a higher surface or up on top of a ladder. So this way, this wider footing on the bottom of it will give it a sturdier base. Also notice on the side, there's a magnetic plate so that you can attach your gauge to the fan itself. That way it's not lying on the floor for somebody to step on, and just keeps things more organized that way. We're also going to offer a shorter umbilical cord for it, so that way that it can attach to the top of the gauge like normal, but then just stretch over to the top of the fan and plug right in on the other side. So that way you just don't have a bunch of tubes and cords lying around on the floor, just to keep it all nice and neat together. So another difference is the high impact plastic shell. It's the same plastic that our blower door shells are made out of, so that high impact plastic, so it can take a little bit of abuse that way. So why do we care about duct leakage? Why do we test? In some states, it's required by code for residential new construction to be tested. Also, HVAC companies also use duct leakage as part of their quality control program that they do, just to make sure that their installations are up the highest quality. They'll go in after their installers, or even have their installers test their own work. One thing that leaky ducts can cause, of course, there's higher energy bills, the comfort issues, but there's indoor air quality issues as well, especially if you create condensing surfaces through leaky ducts, creates an area for mold to grow and things like that. So we definitely want those duct systems nice and tight, especially if there's duct work on the outside of the envelope, which where I'm located in the southeastern part of the country, that's where we typically see your ducts in the attic and ducts in the crawl. So you definitely don't want to be pulling in outside air or pushing in conditioned air to the outside. So just some examples of what not to do or what to look for if you are testing ducts, some of the culprits that we see in the field. These are two examples of basically just bad installs. You can see where this red arrow is pointing. A piece of flex there looks like it tore on that boot, creating a big leak there. Also on this other one, this collar attached to a plenum, that hole looks a little bit too big for that collar, and so it's creating a big hole around the side of that there. So that's going to create some major leakage as well. And another part that counts as duct leakage is where supply boots and return boxes attach to the ceiling drywall and to the floor assembly. So you can see here in these photos where it's caulked around the edge. That's something that you want to seal up, because that does count as duct leakage. And another example here in the ceilings, this is a typical system that's installed in an attic. And you can't see any leakage if the registers are there, but if you were to pull them down, sometimes you can see this gap between the drywall and the supply boot here. So that actually counts as a big hole. And usually what I've seen when I've been out in the field testing, Installers are usually pretty consistent. So if you see a hole around one supply like this, or a gap or a crack, chances are all of them or most of them are like that as well. So think about how many that adds up to be. That's a pretty big hole. So usually if you seal that up, it'll bring that duct leakage number down significantly. And then not only supply boots, but return boxes as well. So this is a perspective of if you were to stick about half your head into a return box in the ceiling, you can see this gap between the ceiling drywall and the return box. So that's something that you would want to seal up to with caulk or mastic. Tapes usually don't last too long there. Other locations where your air handler cabinet attaches to a supply and return plenum, you want to make sure that connection's sealed up nice and tight as well. So unlike this picture where you see a massive crack where that filter, looks like that might be a filter slot, but either way, there's a big gap there between that air handler cabinet and that plenum. So you want to make sure that's going to be nice and tight as well. In the new ResNet 380 standards, if you're a HERS rater, you'll notice that you cannot test ducts without the air handler installed, because that air handler can be a large proponent in the leakage equation there. And not only that, but the air handler itself, all the penetrations that you have going into it for wiring, even the punch outs for different slots can add up for leakage as well. So you want to either mastic or tape or caulk that up. And in my experience, some of the biggest failures that I've seen are when people try to use part of the floor joist or part of the stud bays as the duct system. That usually doesn't turn out too well and ends to be pretty leaky. This is a pretty terrible example here on this bottom picture where they're using a floor joist as a return, and they also have plumbing going up through it, so that's not going to work well. But even if you don't have something that's this bad, even if it is just the floor joist being used as a return, it's really hard to get that sealed and tight. Sometimes you can't reach certain spots to get it sealed up, especially if it's on a first story ceiling where there's a second story above and everything's dried in. If it fails, it's really hard to get to those spots. So usually you just want to use either just hard duct or flex or duct board or something, and not just use the empty space in the floor assembly. And then usually if you see a bunch of duct tape on something, usually that's not going to hold up either. You would think that duct tape would be good for sealing ducts, but it is not. There's better products out there. When you see duct tape, it should be just to kind of hold up that liner in place, but not to actually seal air leaks. And then also look for filter slots as well. Sometimes those can leak. If there's a filter right there at the return plenum, sometimes it's kind of hard to get those sealed up nice and tight, especially if they built a little custom door or something like that that's not sealed. That's a spot to look at. So how do we seal ducts? What's the best way to do that to get a nice low leakage number? Through my experience, I used to do duct testing through Advanced Energy's System Vision building performance program here in North Carolina, and we had a total duct leakage target of 3% leakage for the house. So 3% total is getting pretty tight. And the way we did that, the way we train contractors, is use bucket mastic on every single connection. And a rule of thumb for that is to apply it as thick as a nickel. So don't put just a light thin coating of it. Really get it on there and put it on every single connection. So anywhere that there's a collar attached from a trunk line going to a branch, or splicing collars, or your elbows, any kind of boxes, seams in the return boxes or supply boots, you want to make sure that those are painted over with mastic. That's how you really get a good tight duct system. And then connecting, I'm in the Southeast, so we have a lot of flex duct down here. You can't just really tape it up there and hope for the best. You want to use, after you put your mastic on, use panduit straps like this with the panduit wrench. Don't just put them on hand tight, because usually that doesn't cut it. You want to use the wrench to get it nice and tight on there. So we'll go into some duct testing methods as far as getting the system set up so that you can run the test. So we'll first look at total duct leakage, and that's where we're looking at leakage that leaks both inside the house and outside the house. Pretty much if it's air leaking outside of that duct system, period, this is the type of test that you'll use. So part of that is before you go into taping stuff up here, you want to make sure that your HVAC system is turned off. The last thing you want is that fan kicking on after you have everything taped up or blocked off. And if it has a ventilation system built in, well, a lot of times if it's a ventilation system, it'll just have a duct that ties in to the outside, to the return side, and sometimes it'll have an air cycler control. So you want to make sure that's off too, because sometimes that can sneak up on you and kick on in the middle of your test. So you don't want any fans in the duct system kicking on at all. So just make sure that all of those are going to be off. And another thing to think about too is if it's a zone system, you want to make sure that all your zone dampers are going to be open. If sometimes you have one closed, it doesn't connect to all the duct system, so it'll give you a funky reading or make it look like there's a huge hole somewhere where there's really not. So you want all dampers open, and then you want all fans off. So that's just one thing to think about. But after you have your system set up and ready to go, you'll get some duct mask tape, like you see this blue stuff here that this guy's using to tape onto the ceiling supplies. You'll go around and tape all of those off. And then you'll leave one. It's usually the supply that's closest to the air handler. You'll have that as your probe that you'll put up into the duct system, and that's what's going to measure duct pressure. So that's how the gauge knows when the duct system is at 25 pascals. And there's an alternative to the tape. You can also use the vent cap systems or duct block, and these are just reusable caps that you can use that have gaskets on them so that you can create a nice seal around it, nice and tight. This works really well in smooth ceilings. If you have textured ceilings, sometimes this can be a little tough to work, and tape might be your best bet there, but as long as you have a nice smooth surface to adhere it to, these work really well. And so with Retrotec's duct tester systems, it comes with a clear flange, and this is designed to attach to the grill for the return. And this will work with your typical return grill. It has two adjustable hooks on it so that it can hook right onto the grill itself, and it'll give you a nice flanged edge here so that you can tape around the rest of it. And this is where the system attaches to the duct system. And you can also attach it at the air handler itself. So if you take that service door off, you can attach there. For sometimes if you have a radial system where there's not really a main return, there's just a bunch of small returns in different rooms, it can be hard to access. So that way you can pull that service door off of the air handler and attach there as well. But as long as you have a main return, this works really well. And it's the same diameter as the Minneapolis duct blaster flex as well. So you can buy this flange separately if that's the system that you use, and it'll work well with that too. And it just makes it easier, especially if you have a return in the ceiling. That way you're not fighting gravity to try to hold up your flange with one hand and tape it on with the other. It just takes a lot of the frustration out of setup. But setting your system up is the longest part of this process. When you get it down pat, and even if it's just a single family, single story home, that's just one story, usually it's about a 30-minute setup just to make sure that you go around and get everything taped up right, getting your flange set up, making sure you didn't miss anything. Then running the test itself is pretty fast, but it's usually good just to go around and double check to make sure that way you don't have any surprises when you turn the fan on. And so we've got a little diagram here to show how this works. Before you turn the fan on, you do want to make sure that the system filter is removed. You don't want that in place, so go ahead and take that out before you hook up the fan. And like I mentioned before, you can do either pressurization or depressurization. I recommend to do depressurization. That way it's pulling all the tape that you pulled on your supplies and your returns, it's pulling that up tighter. Because if you pressurize, sometimes it can blow that tape off, and it can be pretty frustrating to go figure out which one blew off and then tape it up there better. So it's just a lot less frustrating if you just go ahead and depressurize. One thing that I didn't mention earlier too, if you're doing a house at the final stage of construction, open a window or crack a door. You want to have the same pressure outside and inside of the house. So you want to make sure that you do that as well. Some people like to test in both directions to do depressurization and pressurization. Sometimes for different diagnostic tests where it locate leaks. With the Retrotec duct tester, it's super easy. You just pop the fan off. There's what we have a quick connect collar, so there's no Velcro or anything like that, or there's no ring you have to completely undo. You just snap the fan off, flip it around, and snap it back on. So changing direction is really easy. And as I mentioned before, 25 pascals is our magic number that we want to test to. We test every single house to 25 pascals when we're doing a duct test. And so, if you're depressurizing, you'll hit to negative 25. Pressurizing will be positive. And then you'll read that on channel A. And then channel B is what's going to tell you your actual leakage number. And so when we're looking for a leakage number, that's going to be a percentage of the floor area served by the system. A lot of codes require 6 to 8%, or if it's going to be a certain CFM per square feet. So 6 CFM per square feet or per 100 square feet, and you can actually set that up in your gauge to do that too. So we have some arrows in here just to kind of show. These blue arrows are just the air movement pathway because we're depressurizing this duct system, so we're pulling air out of the ductwork and through the fan. And then these little orange arrows are that's leakage. Coming into the leaky points of the duct system. So if we were to do a duct test on this fictional assembly here, and we got 140 at CFM 25, and our area of our house is 2,400, that would equal out to 5.8 CFM per square feet. You don't have to do the math like that. You can actually go into your gauge and tell it the area of the house, and then you can set it to give it your reading per 100 square feet, and then it can just give it to you automatically. So that was really about that was your total leakage test, assuming that the house is finished. Some people like to do this test when it's at the rough end stage of construction, which if you can, I highly recommend doing that, because if there are problems with the system, it's a lot easier for them to come in and fix it before everything's dried in. Usually when you have your drywall and everything hung, it can be hard to get to certain spots, especially if it's a 2-story house where you have ducts between floors. Usually, if there's a problem there, too bad you can't get to it without removing that ceiling. So I'll talk about some items here that makes that process easier. So I mentioned before, whenever you block off your supplies or your returns, using tape or the vent cap systems here, but if it's at rough end, you can't really use the vent cap system or the duct block, but you can make your own plugs. You can actually make little foam plugs. This is out of an old couch cushion, so you can make them a little bit bigger. Usually for supply outlets like this, it's going to be a 4-inch by 10 or a 4-inch by 12-inch. So you can just cut them to that size and squeeze them in there and then reuse them. And it's a lot faster than dealing with the tape too. You can just pop it in there and move on to the next one. We use something similar to this whenever I did testing every day for Advanced Energy. We had some foam plugs that had rope handles on them so that we could just yank them out whenever we were finished up. So this makes it easier, and then saves you on cost too, so you're not using tape all the time. We also created a battery pack option for the duct tester. We don't make the battery. There's another company that makes the battery, but we make the cord for it. But this came in handy a lot of times whenever I was doing duct testing, especially in rural areas. When you come into a house like this at the rough end stage, doesn't have power yet, as a temporary power pole outside. But there's been some cases where the temp pole was up by the road and the house was way off the road, and I get there and my extension cord isn't long enough. But if you use the battery pack like this, you don't have to worry about that. You're bringing your own power with you. So there's this company called Leaf Bike. They're an electric bike company, and they make this battery that's designed to fit on the back fender of a bicycle. We just make the cord to attach from the battery to the duct tester. So I'd like to thank Aaron Martin with Green Door Energy in Greensboro, North Carolina. He sent me this picture. He's been using his for a little while now, and it's working out well for him. So it's nice. You don't have to carry an extension cord around. You don't have to worry if the house has power or not. You just bring your own power with you and keep trucking. And I've got a link down here. I know you can't click on it, but you want to take a screenshot, or we'll have this posted up on YouTube later. You can come back and see where that battery is located if you want to order one. Another thing that I recommend to keep on hand if you're doing tests at rough-in is crawl space tape. And this is after a few years of trial and error with different products. The good thing about, I mentioned using bucket mastic earlier. It's great for sealing ducts, but tape does not like to stick to it, or the duct mask anyway. But this crawl space tape, which is used to seal up liners in a crawl space, actually sticks to wood and mastic better than anything else I've tried without tearing things up after you pull it off. Don't put it on drywall. Don't use it in place of your duct mask, but you can stick it onto wood and mastic, and it works out pretty well. And we actually sell some white tape like this. So if you do a tape order and you do testing at rough-in and have been dealing with this, add a roll of this in and give it a shot. So this is just an example of what I was talking about here. This is a return in the ceiling, and you can see this white stuff here. This is bucket mastic around the edge. So my duct mask isn't going to stick to that, especially if I put weight on it with my flange in here, putting pressure on that tape. It's just not going to work. So I used the white tape to go around the edge and gave myself a brace in the middle to hang my flange here on this side, and then just finished off the rest here with the duct mask. And it worked pretty well. So it'll actually support the weight of that flex hanging down from the flange. And going around and taking photos and some videos the day I did this test, it actually was able to hang there for a couple of hours and didn't let me down. So it's just a good process that I found that I figured I'd pass along. So we talked about total leakage, and we'll get to leakage to outside where we use a blower door, but I'll check in with my buddy Lee here, who's online with us, to see if we have any questions in the box. Lee, anything in there?
Yeah, we did have one question. Andrew was asking, when you're doing the mastic sealing of the duct seams, should you be using mesh over those seams to kind of secure everything in place?
Yeah, I've seen people do that, and that's a good process. A lot of the contractors that I've seen here in the field in North Carolina didn't use the mesh, and they were still able to get pretty tight numbers without it. But yeah, the mesh definitely helps. So thanks for bringing that up.
Is that is it just security for the connection, or what's the purpose of that, if you don't mind me asking?
Yeah, so it just helps keep everything in place, and it just makes it a cleaner job too. So, a lot of people don't like using the mastic because they get it all over the place, but if you use the mesh over the top of it, it just makes everything slide on a little bit better, especially when you're bringing that piece of flex over that collar. It just kind of keeps everything in place, and then the pressure of that mastic coming through the mesh really helps out too whenever you pull the flange over the top. So yeah, it just makes it for a neater job.
Okay, perfect.
Yep.
The other thing was a couple of people were asking about the clear flange. I just wanted to mention that the hook length on those can be customized. So if you're running across a return that has a thicker than normal grill, we can make those with longer hooks. Just send us an email, let us know.
Excellent. Thanks.
All right, that's it.
Cool. Yeah, we'll move on to leakage to the outside. Usually if you're testing to code, there'll be, depending on what state you're in or what code you're testing to, there'll be two different targets. They'll give you a leakage to outside target and a total leakage target. What we've done in the past, if we're trying to meet code, if we couldn't meet, we'll try to do a total leakage test. If it failed, sometimes we could get it to pass with leakage to outside. But with this test, you will need a blower door to be running at the same time. And so this is just a couple of pictures here to show what this looks like. We've got our duct tester hooked up the same way as if you would do a total leakage test, but you just have a blower door that's going to be running at 25 pascals just to pressure match that of the pressure in the system. That way, the only leakage that your duct tester is reading is leakage to the outside and not leakage to the inside. So really, there's two different ways you can do this. There's method one, method two. Method one here, if you look at this diagram, these things that look like car batteries, those are representing your gauge, your DM32 or DM2, whatever you're using. With method one here, the hose that you use to go to the outside, you'll split that off from your blower door, and run another end over to your duct tester. And then run everything else the same way. So you'll depressurize the house to 25 pascals, and then you'll depressurize the system to 25 pascals. That way, your duct tester is only reading leakage to the outside. But what most people do is method number 2, where you don't have to splice that hose. And people like this because not every scenario do you have a hose long enough to make those gauges meet. Sometimes your blower door will be in one spot, and then you'll have your duct tester set up upstairs at the other end of the house. So that doesn't always, method 1 doesn't always work out well for everybody. So method 2 allows you to keep those gauges separate. So blower door is going to work the same way. You still depressurize to negative 25 pascals. Just on the duct tester, you'll have it set up as if you were doing a total leakage test. But instead of going to negative 25, you're just going to seek 0 pascals. Because that blower door is already going to be pulling that duct system to negative 25. So you're just going to make it pressure match by hitting 0. Since that gauge isn't communicating with the gauge of the blower door, it doesn't matter. You already know what it is. It's negative 25, so just make it hit 0, and it works the same way. We have this diagram on our website if you want it. I know it's on the one of our older quick guides. It's for the DU200 model used with the DM32. So we have all of those quick guides on our website, so you can go snag that from there, or you can just take a screenshot of it right here if you want to. So that's basically it for leakage to outside. You're just using a blower door just to pressure match the house with the duct system to remove that internal leakage from the equation. So now we'll talk a little bit about locating leaks in the duct system. One way to do it, we're going to pull our blower door back out again and use a pressure pan. So this, you'll run a basic blower door test at 50 or negative 50 pascals. And then, like you see in this diagram here, you'll take your pressure pan and put it over your supplies. We make a larger pressure pan too that'll fit over most returns, so you can do both supply and return side tests with this. And basically what you're doing, you're not looking for a specific number. You just want to see if there's a significant pressure differential between the duct system the duct that you're testing and the house. So if you're getting a big difference, if it's getting up to 7 to 10 pascals, that's pretty significant. This just allows you to locate which branches are giving you problems. It doesn't tell you how leaky it's going to be. It just shows you if there's some leakage there. So as we're depressurizing the house with the blower door to negative 50, air is going to pull in from all sorts of places, especially if it's a leaky home. But if the duct system's leaky, it's going to pull air through those leaky spots and then out those supply and return grills. So that's just what we're looking for with a pressure pan. And here's just a few photos of what that looks like. I've got our blower door set up, and then we're just going to put that pressure pan firmly over that supply outlet. You can do this, if it's a supply over the floor or in the floor or in the ceiling, it doesn't matter. And we'll set our gauge up. We'll have both channels reading pressure. So we're just looking for a pressure differential between that duct system and the house. And that's usually step 1. Some people even do this before they run the duct test. They'll just go ahead and set the blower door up and see, especially if it's a quality control thing that an HVAC contractor's doing. If they go around and they're not getting any difference between that duct system in the house, then they know the duct system's going to be pretty tight if they go around and just check every supply. If they do run a duct test first, they'll go around and do that just to at least give them a general idea of where their problem's going to be located. And then the next step would be to do some smoke testing, so you can really narrow it down to show you what connection is giving you a problem. So this is the Tiny S handheld fog machine that we distribute. A company called Look Solutions make this. If you've never heard of it before, they actually make fog machines for the film industry. So we came across this a few years ago and thought it would be perfect to use for building diagnostics. So some of you might be familiar with the old school smoke pencils that we don't carry anymore. We can't even ship it. It's a hazardous material, the titanium tetrachloride. But this stuff, it's just a glycol solution. It's even a food grade glycol solution. So it's, if you inhale it, it's okay. It doesn't corrode metal. We've had some really good feedback from this in the field, and the vapor that comes out really behaves like a smoke and hangs there in the air nicely. So it's really good for testing air currents and leaks. But you can see here the case that it comes in. You can refill the cartridges yourself. It comes with, I think, 7 of these cartridges. And then there's one big tank of fluid. And if you run out of fluid, I think a bottle of that's like $15 you can get off our website. It comes with 2 rechargeable batteries. And one cartridge of fluid will last about 10 minutes if you just hold the button down. But yeah, usually 1 cartridge of fluid, if you're testing a few houses a day, that'll last you. Also talk about a couple of apps that makes duct testing a smoother process in the field. Some of you may have heard of our cloud app. This is our automated testing app. Works great for blower doors, but works for duct testing as well, so that you can generate a customized report for the house that you just tested. And it gives you the ability, if you're doing this for a customer, you can just email it to them right off your phone right after you finish the test. So you're actually running the whole test on your phone, and then you connect it with your email account, and then shoot it right over to them, or shoot it back to your office, email it to yourself, whatever you want to do with it. Shoot it to a code official if that's what they want to look for. As we've been going around talking to code officials across the country, they're loving this because it geolocates where you are, proves that that's the house that you tested. You can't fudge the numbers on it. As far as testing and generating a report all in one motion, this is the tool to use. And the thing about it is you don't have to be connected to the internet to use it. So if you're out in a rural area where you don't have a good connection, or if you're using a phone or a tablet that doesn't have a 4G or LTE connection on it, you can still run the test, and then when you get back home or back to the office, you can just upload it back when you get there. So it's a really handy tool to use just to stay organized and keep everything together. Keeps you from having to write things down in a notebook or keep a laptop on you. And if you pull up the menu on our cloud, this is kind of what it looks like. Geolocates where you are on the map. If it's an existing home, it uses data from Zillow's database, so square footage and everything like that's already in there. And puts the map on the report for you. And this is just a, well, this is an older report without the map on it, but this is an example of a blower door test that was used in our cloud. And if you have a certain target that you're trying to hit to meet a certain program or to meet code, it'll tell you if it passed or failed there right at the top. Gauge Remote app for duct testing. This thing's really great, especially if you're just a one-man show. It keeps you from having to crawl out of a crawl space or come down an attic to adjust your fan speed. Basically what this does is mirror the DM32 screen onto your phone and gives you controls of your fan anywhere in the house. So that way, if you're trying to look for leaks up in an attic, you can just take your phone up there with you, pair with the gauge, and then you can have your smoker in one hand, your phone in the other, and just keep trucking and not have to keep crawling down out of the attic and then going back up to adjust your fan speed. So sometimes if you're doing smoke testing, I like to depressurize the duct system and then puff it with smoke and watch it get sucked in. So turning the fan speed up sometimes helps with that. So yeah, so that's testing. Yeah.
I was going to say, we're going to answer a couple of questions here that came up. Our cloud, Andrew's asking if that's a subscription service. So it's currently, our cloud is no cost. Eventually, we're going to be rolling in a billing or a like a charge schedule for that, and I believe it'll be a certain cost per test location. So if you do multiple tests at one location, it's going to be that one initial test fee, and it should be around a couple dollars, although I'm not positive on the actual pricing as of yet. I believe that is later this year, but we're still discussing it as far as I know. There's another question about Gauge Remote app. Gauge Remote unfortunately does not work on the DM2. All of our smart apps and things that are designed to work over Wi-Fi are going to be DM32 only. I believe, let me see, virtual gauge on the PC may work with the DM2 for speed control, but I think as far as directly viewing the gauge and changing settings, that's only DM32 related. And Jonathan was asking if we have purple smoke available yet. I'm not aware of any colored smoke, but that wouldn't be a bad idea. I think the fear is that it leaves residue, though.
Yeah, we've talked about that before. Yeah, colored smoke, the dye in it can cause it to gunk up. But no, it'd be really cool. I'd love to have red or yellow smoke.
And then one last one, the computer apps, they are Windows-based at this point. The only one that's not purely Windows-based is going to be rCloud. And that is available on iOS. It's not natively supported on Mac computers, as far as I know, but mobile devices it would be, iPads and your iPhone and that kind of thing. All right, Sam, I'll hand it back over to you.
Cool, thanks. So the last item I wanted to cover is calibration and field check. So sometimes if you get in the field and you're getting a funky reading on something and it's not your test setup, you start looking at your equipment. So here's how you check to make sure that everything is running properly. So we'll start with a gauge. So to field check your gauge, basically what you're doing is you're just going to use one piece of tubing. So if it's your umbilical that you're using, just go ahead and get one of them. So make sure they're the same color. So if you're using the yellow like you are here, get one end on the A channel and put the other on a port on the B. And you're just going to test every port against each other. And basically you want to have the same reading on channel A and channel B. So you'll set your gauge to read pressure in pascals on both channels. So like here, it's kind of like if you've ever put a hose on your gauge and then held the other end with your thumb, you'll get a reading. It's because it's building a pressure in there when you close both ends off. So same process, it just tells you what that pressure is, and both channels should be reading the same. So like I said, you'll set both channels to read pascals, and then you'll just use the same piece of tubing to test each side to itself. So you'll go blue to green, then blue to yellow, and then you'll switch on the channel A from blue to red. Oh, well, I guess I didn't have any slides of that. But you can see it here at the top. Those are all the different combinations that you would use to test that out. And you really want it within 2% of each other. So really just a fraction of a pascal if it's going to be different sometimes. But when I've done this in the field, I've never really seen one fail yet. But that's how you check your gauge, just to make sure that your sensors are working well. If you were to take the backing off of that gauge, there's actually smaller tubing that attaches these ports that goes to a switch and then to a sensor. So this is to ensure that that tubing's not leaking or anything like that, that your pressure switch is good, that your sensors are good. So that's how you check to make sure that everything on your gauge is working as it should. Another thing to do while we're talking about your gauge is just make sure that you're on the latest firmware version. And you can see what version you have on the splash screen or down at the bottom. Whenever you pull the main screen up, you can also go to your settings and flip through to the very end of your settings menu, and it'll tell you what firmware version you have. And if you want to update your firmware, if you've never done this on your DM32, go ahead and give it a shot. You just go to our website, and you can go under software, and you can find the DM32 Configurator. Don't look at that current build because I think it's a little old. But if you go to our website, the DM32 Configurator, it doesn't cost anything. Just go ahead and download it onto your PC, and then you can just plug your gauge up to it with the USB charger cable. It'll find the gauge and then get it up to the latest firmware version. So that's what the icon looks like if you go to our website. Tubing's as simple as it is. That's another thing that can cause a very serious misread, especially if you get water in it. I've had some rainy days where this has happened to me before. If you do get water in your tubing, please don't blow on it, especially if it's still attached to your gauge. The last thing you want to do is get water inside your gauge. So if you get water in there, the best thing to do is just sling it around to get it out. Think about how small that hole size is on your tubing. It doesn't take much to block it. So one little drop of water can block up the entire tube. So keep those high and dry. Make sure you don't drag them through a puddle or anything like that. So because that can really screw the whole test up. But yeah, Just remember, if you get water in there, just sling it out. Don't blow on it. Sometimes moisture from your breath can just add more water to it instead of help it. So give it a good sling, and that's the best way. And then just hang it up to where everything's stretched out so that it all drains out if you do get water in there. That way it just doesn't stay if it's coiled up in a box or something like that. So now we'll talk about checking your fans. Like the gauges, there's smaller tubing in here that connects from the port up to where pressure is collected at the fan opening. And on the 300 model, that happens in 2 spots. So you've got your yellow port and your green port. They collect pressure readings from 2 different spots. So we'll talk about the yellow port first. So you can just use painter's tape on this. You can see here these little strips. If we were to zoom in, like on this picture here on the bottom, these little holes are where your pressure reading is coming from when the fan's running. So if you block all of these off, it's the same as just holding your thumb over the end of the tube. It should all be blocked off, and it should give you a pressure reading. And then what you do is just release them one by one. So you would take one piece of tape off, and then it should go down to 0. And then you put that piece of tape back on, you'll get your pressure reading again, and then move on to the next one. Take that one off, should go down to 0, put it back on, move to the next one. What this tells you is it's going to make sure that all those ports are open, and that there's not like drywall dust or sawdust or something in there clogging one of them up. So you want all those ports to be open and clear, and this is how you check that. If you hook to the green port, it reads from 4 points on the outside of this red ring here. So if we zoom in, we can see here there's this little hole here on the ridge. That's where that pressure is being collected. Obviously, since this is a ridged surface, you can't use tape, so we say use silly putty, and only silly putty. Don't use clay, don't use Play-Doh, as that can leave it clogged up. Silly putty will stay in one piece when you take it back off. So yes, there is a technical use for silly putty. And a rule of thumb, if it's a textured or rough surface, use silly putty. If it's a smooth surface, use tape. So as we go to the DU200, this opening, this red opening here, is going to be a little different than the 300. Here, the 300, it's smooth. You can use tape for the yellow port, like we talked about. But on the 200, it's textured. It's a little rough. So you have to go back to your silly putty. And on this model, there's just 2 points where those little holes are there. So you use your silly putty there to stop those up for the yellow. And then for the green, you've got 2 on the outside on the opposite ends, so top and bottom. You'll, again, use silly putty there just to block those up. And then release them one by one, just like you would on the other one. Just to make sure that those ports are free and clear. So as you take one off, it should go back to 0. As you put it back, it should go back to give you a pressure. Then you check the other. And if you have a blower door, it's the same way. You can do your fan fill check the exact same way. Just cover your pressure ports on the blower door, and it's the same process using silly putty. So again, you do this one by one. Once you take one off, be sure to put it back, and then move on to the next one. And then just to make sure that your fan and everything is working correctly, the way you do that is you have a known hole size at the end. And if you know what the hole size is and what the flow rate should be for that hole, you're good to go. We actually make a calibration plate that can be attached to your clear flange and taped inside, and it'll tell you exactly what that flow should be at 25 pascals. And it's just a 4-inch hole. But you can make your own too. We have some instructions on how to do that. And then on your quick guide for the duct tester, there's instructions on how to do this as well. But using that calibration plate just tells you that everything internally in the fan is working as it should. The gauge is reading the right number. So that's just a quick and easy way that you can just field check all your equipment to make sure that you are getting the right readings that you should be getting. So that kind of wraps us up here at the end. We're going to put this on YouTube when we're finished up. So that way, if you have a colleague or somebody that you want to, go back and read this or view this, they'll be able to. We'll have it up by the end of the week. And then just wanted to toss my info there too. That's my email address. Easy, just sam@retrotec.com. If you have questions or anything, feel free to shoot me a message, and I'm happy to help. And so I'll check in here with Lee again to see if we have any more questions in the box.
Yeah, actually, just one topic that came up previously, and that's the difference between gas and electric systems for duct testing.
Yes.
Do you have any comments as far as how the differences for how they're sealed and prepared, and what kind of differences in leakage you should expect from those?
Yeah, sure. It should be the same for both. The whole combustion process on a gas system should be completely separate from anywhere where there's going to be airflow. So it's really going to be the same. If you have a sealed system, I mean, there's no need to tape off your intake and exhaust there. It's completely separate from that. So really, a gas system really shouldn't be leakier than a heat pump or something like that. I mean, it's really just the same process. It's all about how that duct was installed and how it was sealed. That's going to give you problems. So that's my feedback on that.
Okay, excellent. One other topic that came up previously was fresh air supplies, and if you have a fresh air supply that the external vent or intake is difficult to get to, do you know what the rules are as far as do you have to seal that or when it should be sealed for doing duct testing?
Yeah, I mean, if it's not running continuously, uh, it should have a damper on it. And I know not every installer does that, but and a lot of the ones that I've seen that are like ASHRAE 62.2 that have an air cycler fan, it should have a motorized damper on it that's sealed. And a lot of those actually seal pretty well. If there is no damper on it, let's see, if I go back to, let's see here, that one picture that I had, here we go. So this other hole here that you see is the fresh air. And if you look up in there, that's the motorized damper. And then this contractor actually put a secondary damper to adjust airflow if it's getting too much or too little. But that this butterfly damper up here actually has rubber seals on it that actually seals it up pretty well. I've tested a lot of these taped and then tested again without tape and really haven't seen much of a difference. But if one of these doesn't exist, then it's going to leak. So throwing some tape over this side if you can. And contractors that I work with, I tell them to do it like this. If it has a duct just running into the return plenum where I can't get to it and it's up on like a third story, there's really not much you can do without taking that supply or taking that ventilation off, taping it, and then reattaching it. But if the standards you're testing to require that to be taped off, then I mean that's what you got to do. Because usually if not, and there's no damper, it's going to be a massive hole there. It's not going to pass.
Right. Okay. Awesome. Great info. Thank you.
Yeah.
And I believe that is it for questions.
Excellent. Well, thanks for tuning in, everyone. Again, we'll have this posted online. Just go to YouTube and search Retrotec Energy, and you'll be able to see our YouTube channel there. And be sure to stay tuned for our next webinar that we do. Thanks again.